Just a quick review. A blank is a number, a variable, or the product of a number and one or more variables with the whole number exponents. Nope. Oh, it is a monomial. It's also a term. Monomial is a number, a variable, or the product of a number, one or more variables with the whole number exponents. Okay? What is not a monomial? 5 plus x, a sum, is not a monomial. Okay? So this is not a monomial. That is a binomial. There are two. 2 divided by n is not a monomial. They can't have variables in the denominator. 4 to the power of a is not a monomial. It cannot have a variable in the exponent. X to the power of negative 1. Exponents of monomials must be whole numbers. The degree of a monomial is the sum of the exponents of the variables of the monomial. The degree of a non-zero constant is 0. So that's like we talked about. So if you have the constant 3, its degree is 0. Okay, so that answers our question from earlier, Jack. Not right now. Okay? 0 does not have a degree. So the number 0 has no degree. Okay? All right, so for example, the monomial 10, what is the degree of 10? The degree of 10 is 0. The degree of a non-zero constant is 0. So the degree is 0. What is the degree of 3x? 1. What is the degree of 1/2 ab squared? 1/2 ab squared is 3. Because you have to take the degree of a, which is 1, the degree of b, which is 2, and add those together. The degree of negative 1.8 m to the 5th power is 5. Okay? All right. So a blank is a monomial or the sum of a monomial, a polynomial. Okay? It's a monomial or a sum of a monomial. Each monomial is called the term of a polynomial. So each monomial is a term. The degree of a polynomial is the greatest degree or exponent of its terms. So, for example, if we have 2x cubed plus x squared minus 5x plus 12, it's a polynomial. The degree of the entire polynomial is 3. Okay? We don't add them to find the degree of the entire polynomial. It is just the one that is the largest, which is 3. Okay? We always write polynomials in descending order so that the degree decreases from left to right. So anything you don't already have in your notes, you should be adding right here. Okay? The leading coefficient is the coefficient of the first term of the polynomial. The leading coefficient is the first term of the polynomial. Okay? So, okay. What is a polynomial with 2 terms called? Binomial. You can just say it. Trinomial. Above 3 terms, we just call it a polynomial. So let's classify it. This, is it a polynomial?
No.
Yes. What is it called? What is the degree?
0.
0. Okay. Expression is 9. It's a monomial. Degree of 0. Is this a polynomial? Yes. What is it called? What is the degree?
3.
Hold it up on your fingers. The degree is 2. Remember, the degree is the degree of the largest degree is the degree of the entire polynomial. Now, if this was 2yx squared, the degree of this would be 3. So the degree of the entire polynomial would be 3. Okay? Yep, don't count them together when you're finding the degree. George, stop. All right. Is this a polynomial?
No. Yes. No. Yes.
Thumbs up, thumbs down. Is that a polynomial? Yes or no? Right here. No. You can't have a variable exponent. Yes, you have. You cannot have a variable exponent. Okay? So there is no degree because it's not a polynomial. Is this a polynomial?
Yes.
Yes. What kind? Binomial degree? 2. Is this a polynomial?
Yes.
Yes. What is it called? Binomial. What is its degree?
8.
So the degree of this one is 5. Okay. So we're going to look at 2 different methods for adding and subtracting polynomials. We did one the other time. We just went and we did the like. One way you can do it is you can align like terms in vertical columns. So in this case, you will notice that we have 2 expressions. The 2 expressions are being added together. So one way you can do it, and this might be a good way to make sure you remember to do all of the steps, is you start with the original expression, or the first expression. So we have 2x cubed minus 5x squared plus x. So we have 2x cubed minus 5x squared plus x. The next step would be to take the terms from your second expression and line up like terms vertically. So for example, here we have an x cubed, here we have an x cubed, so this is written right under there, vertically, like in a column-ish. Okay? Here we have an x squared, here we have an x squared, so we lined it up right underneath. Here we have an x, there we don't, so we have nothing under there. There we have a -1, there we don't. And then add vertically. When you add vertically, you have 2x cubed plus x cubed is 3x cubed. -5x cubed plus 2x cubed, 5x squared, 2x squared is -3x cubed. Squared. X plus nothing is x. -1 is -1. So that's a different way to do it, by just kind of putting them together. The other way to look at it is look at them horizontally like we did, where you group them in order, and then you add the like terms together. Okay? I want you to do this problem using both the vertical method and the horizontal method. So if you did it vertically, you will notice down here. Let me see if I can scroll it down so we can see a little bit more. Okay. Okay? Notice on here, we had a -x cubed plus a +x cubed, which gave us nothing. We had a -2x squared plus 3x squared, which gives you x squared. You have a -3x, and there was no term with just the variable x. So you have 3x, -12. There was no term, no just constant in that one. So you have x squared plus 3x plus 12. -12. Oh, that's a typo. It's minus. See, that would be part of those, whoever typed this one out, they did not double check their work and they just automatically did plus, because this should be minus and that should be minus. And they didn't double check their work. All right?